Why do engineers place engines in different locations on planes? Have you ever looked at an airplane and wondered, why on earth are the engines in such different places on different planes? Some have wing-mounted engines, podded engines, others at the back or tail-mounted engines, and a fuselage-mounted engines. Is it just a design choice, or is there a deeper reason behind this? Stick around, because today we're diving into the fascinating world of aircraft engineering to uncover the real reasons why aircraft engine locations vary. Trust me, you'll never look at an airplane the same way again. Let's take off. The first one is wing-mounted engines, podded engines. The engine is either on the top or bottom. Engines under the wings, close-up of a commercial jet like a Boeing 737 or Airbus A320. Most commercial airplanes you see today, like the Boeing 737 or Airbus A320, have their engines mounted under the wings. But why are engines mounted under the wings? Because this placement provides several advantages. 1. Weight distribution. Placing the engines under the wings helps balance the weight of the aircraft. This reduces stress on the fuselage and makes the plane more fuel efficient. The other advantage is aerodynamics. The wings generate lift, and placing the engines here minimizes drag, allowing the plane to cut through the air more smoothly. And also ease of maintenance. Engines under the wings are easier and quicker to access for repairs, which is a big deal in commercial aviation where every minute matters. And in case of an engine fire, the risk to passengers is minimized. Fuel feeding is possible in the event of fuel pump failure, as the engines are below the wing tanks. Engines on top of the wings. Now, this one's a bit unusual. Engines mounted on top of the wings. This design is rare, but super useful in specific scenarios. For example, advantages: rough or unpaved. Runways. Planes like the Antonov An-72 have engines on top to avoid sucking in debris from rough, unpaved airstrips, making them perfect for remote areas. Short takeoff and landing. The high placement allows for unique aerodynamics that help certain planes take off and land on very short runways. On some designs, e.g. An-72, engine exhaust flows over the upper wing surface, enhancing lift at low speeds. Special missions. Some military and cargo planes also use this design for added versatility in tough environments. Blown wing effect, Coanda effect. On some designs, e.g. An-72, engine exhaust flows over the upper wing surface, enhancing lift at low speeds. Disadvantages of wing-mounted engines. For undermounted engine, vulnerability to foreign object debris, FOD. Because they're closer to the ground, wing-mounted engines are more likely to sucking in debris, leading to potential damages. Wing stress in turbulence. Heavy engines can cause additional flexing of the wings during turbulence. Longer landing gear. The engine's position necessitates longer landing gear to maintain adequate ground clearance. For top-mounted engine, aerodynamic drag. Top-mounted engines can disrupt clean airflow over the wing, can reduce overall cruise efficiency if not carefully designed. Maintenance complexity. Mechanics need ladders or platforms to access engines. Less convenient than underwing engines. The second one is fuselage-mounted engines. Before wing-mounted engines became standard, many early jetliners like the Boeing 727 and the Hawker Siddeley Trident had fuselage-mounted engines, either at the rear or along the sides. Advantages of fuselage-mounted engines. Reduced wing stress. By placing engines inside or near the fuselage, the wings could be lighter and more flexible. Better short-field performance aircraft, like the Boeing 727, were designed for short runways. Fuselage-mounted engines allowed for a high wing design, improving lift at low speeds. Quiet cabin experience. Since engines were farther from passengers, noise levels inside the cabin were lower. Disadvantages of fuselage-mounted engines. Complex maintenance embedded engines are harder to access for repairs, increasing downtime. Higher risk in engine failure. If an engine fails catastrophically, debris could damage the fuselage or tail. Less aerodynamic efficiency. Unlike wing-mounted engines, fuselage-mounted designs don't benefit from the lift-thrust synergy.
Please like, share, subscribe. Thank you.